Good morning, students. Today we'll start lecture number 2 of unit number 5. In lecture number 1, we discuss about introduction of brake. We also discuss about the basic requirements of good braking systems and the basic requirements of good lining materials. We also discuss classification of brakes and detailed description of single block shoe brakes. In single block shoe brakes, we derive different formulas for different cases. Like case 1, when line of action of tangential braking force passes through the fulcrum points O, and case number 2, when line of action of tangential braking force passes at a distance A below the fulcrum point O. We were derived for the formulas normal reactions, tangential braking force and tangential braking torque. Today we'll cover case number 3 in single block shoe brakes. Case number 3. When line of action of tangential braking force is at a distance above A or from fulcrum point O. Here, please see in a figure. This is the line of action of tangential braking force and this is the point O, fulcrum point. Here at a distance A of tangential braking force from point O. Now, according to this figure, when condition number 1, when wheel rotates clockwise direction, please see in figure. When wheel rotates in clockwise direction, the tangential braking force is in towards right side, this side, and frictional force is in opposite direction of tangential braking force, that is left side, and the value of frictional force mu Rn, that is equal to tangential braking force, this. Now, and same terminology is used previously. Now taking moment about point O. PL is the clockwise couple about point O. P load into perpendicular distance L. This make a clockwise couple about point O. So we assume clockwise couple at positive sense and anti-clockwise couple at is in negative sense. So next couple is Rn into X. Rn is normal reaction. It is in upward direction and perpendicular length X. It makes anti-clockwise couple about point O. So it is in negative sense. Third couple is Ft, tangential braking force and perpendicular length A, and it's make a clockwise couple about point O, so it is in positive sense here. So sum of the couples is equal to 0. PL positive sense couple, Rn negative sense couple, Ft is clockwise couple and positive sense couple. Simplify equation and we obtained PL equal to Rn into X minus Ft into A. Putting the value of tangential frictional force is equal to mu Rn in equation number this, and now obtain PL equal to Rn into X minus mu Rn into A. We can common Rn in right hand side and obtain PL equal to Rn into X minus mu A. We can also obtain equation value of Rn normal reaction is equal to PL upon X minus mu A. Normal reaction values equal to PL upon X minus mu A. Now, tangential braking force. It is mu Rn. Putting the value of Rn from here to tangential braking force equation here. Now we can obtain the value of tangential braking force Ft is equal to mu P L upon X minus mu A. Now tangential braking torque TB is tangential braking force. It is tangential braking force into perpendicular length or radius of wheel or radius of drum. So TB is equal to Ft into R. Small r is equal to radius of drum. So putting the value of tangential braking force from here to tangential braking torque equation here. So we can obtain value of TB tangential braking torque is mu P L into R upon X minus mu A. Here shows direction is clockwise. This is very important. Now see in figure. Ft is in right direction, R is here, and this point is rotation of wheel. So this makes a clockwise couple or torque. Now moves on condition number next. Here when wheel rotates in anti-clockwise direction. So please see in a figure. When wheel rotates in anti-clockwise direction and Ft is in left side because wheel rotates in anti-clockwise direction, and frictional force is opposite to Ft and value is mu Rn and its x rightwards. Ft is equal to mu Rn, and other conditions are similar to previous case. Now come back. Taking moment about point O, about fulcrum point O. PL positive couple, P downward force into perpendicular length. It's make a clockwise couple about point O. Next couple Rn into X. It's in negative sense because Rn is upward force normal reaction and perpendicular length X. It's make a anti-clockwise couple about point O. Next type of couple Ft into A. It's also in negative sense because Ft is in left side force and its perpendicular distance A about point O it's make a anti-clockwise couple about point so. So we obtained equation as PL into minus Rn into x minus Ft into A equal to 0. We simplifies as PL equal to Rn into x plus Ft into A. Putting the value of Ft is mu Rn. Putting the value of Ft from here to here. So we can obtain PL equal to Rn into x plus mu Rn into A. From this equation, we can common Rn from right hand side and obtain new equation PL equal to Rn x plus mu A. From this equation, we can obtain value of Rn as PL upon x plus mu A. This is normal reaction value. Now we can obtain value of tangential braking force. This is equal to mu Rn. Ft is tangential braking force. This is equal to mu Rn. Putting the value of Rn from here to tangential braking force equation here, and now we can obtain the value of tangential braking force Ft equal to mu PL upon x plus mu A. This is tangential braking force. Now we can also obtain as tangential braking torque TB, tangential braking torque. This is equal to tangential braking force upon perpendicular length or radius of drum or radius of wheel. So TV is equal to Ft into R. Here small r is equal to radius of wheel. Putting the value of Ft, tangential braking force, from here and put this value in tangential braking torque equation here. So we can obtain tangential braking torque TV is equal to mu P L into R upon x plus mu A. This. Here direction is anti-clockwise direction. So please see in a figure Ft is in left side force, tangential braking force. R is this, and this is the center of rotation of wheel. So Ft makes anti-clockwise couple or torque about center of rotation of wheel. So the direction of tangential braking torque is in anti-clockwise direction. Now next topic is condition for self-locking or self-locking brakes. We also know case number 1. We develops a formula PL equal to Rn. Case number 1, in which when line of action of tangential braking force is passes through fulcrum point O. In case number 1, PL equal to Rn. In this equation, we can see here the value of P will never be 0 or negative, because P is directly proportional to X. and x will never be 0 or negative. So right hand side never be 0 or negative. So here this is the main point. The value of P will never be 0 or negative. That means we want to apply a load for applying the brake. Now see case number 2 and 3. These are two cases, case number 2 and case number 3. Case number 2, when line of action of tangential braking force at a distance below or above the fulcrum point O. In case number 2 or 3, we can obtain only two conditions. First condition or first equation like PL equal to Rn x plus mu a, and second equation PL equal to Rn minus mu a. These are two equations developed in case 2, either case 3. So please see equation number 1. PL equal to Rn x plus mu a. In this equation we can see here the value of x never be 0, the value of a never be 0. So the value of right hand side never be 0. Here RHS never be 0 or negative. So the value of P will never be 0 or negative. That means we want apply a load for the braking. Now see in equation number 2. Equation number 2 is PL equal to Rn x minus mu a. So here the value of x depends on value of a. That are certain values of x and a. If the value of x is greater than value of a, this is the main condition for self-locking condition. If the value of x is less than value of a, and we are also noted as x is less than or equal to mu a. In equation number 2 is PL is equal to Rn x minus mu a. So if x is less than a, then RHS will be negative or 0. So the value of P will be negative or 0. That means no external force is required to apply the brake. When value of P will be negative or value of P will be 0, that means no external force is required to apply the brake. This condition is known as self-locking condition or self-lock brake. This is very important. To avoid this self-locking condition, it must be x is greater than or equal to mu a, not be equal to x is greater than mu a. X is greater than mu a. This is the condition for avoiding self-locking condition. This condition is also known as self energizing brake, self-energizing brake. Now here all conditions in single block shoe brace are discussed. Now moves on second types of brake, pivoted block brake. Pivoted block brake. Here is mention is 2 theta is greater than 60 degree. Please note it down, in single block brake 2 theta is always less than 60 degree. Please note it down, in single block shoe brake 2 theta is always less than 60 degree. In pivoted block brake 2 theta is always greater than 60 degree. That is equal to 70 degree. That is also equal to 90 degree. So in pivoted block brake we can use mu dash, equivalent coefficient of friction. This is the very important. Here we don't use simple mu, we use mu dash, equivalent coefficient of friction. The value of equivalent coefficient of friction is 4 mu sin theta upon 2 theta plus sin 2 theta. This mu dash. Here mu is actual coefficient of friction that is given in problem, numerical problems, and here 2 theta. Here 2 theta is in radian. If assume the value of 2 theta is given as 90 degree. So the value of 2 theta equal to 90 degree, that is also equal to 2 theta is equal to 90 degree, that is also equal to pi by 2 radian. So in this formula we use 2 theta in radian, and this mu is actual coefficient of friction and mu dash is equivalent coefficient of friction. So TB, tangential braking torque, equal to Ft into R. Ft is equal to tangential braking force, Ft is equal to mu R, and in simple case. But in pivoted block brake Ft is equal to mu dash Rn. Here mu dash is equal to equivalent coefficient of friction. So here TB is equal to Ft into R. The value of Ft is mu dash Rn. So putting the value of Ft in this equation, and we can obtain the final equation is TV is equal to Ft into R and or mu dash Rn into R. This is equation for pivoted block brake, and other conditions are equal to single block brake. Now move on, next type of brake, double block brake. Double block brake. Please see in a figure. This is double block brake. In this figure we see two types two single block brake. First single block brake and second single block brake. Here this is the wheel of rotation or drum. This is the shoe. This is the block shoe. This is also bell crank lever. This is also bell crank lever. This is a spring. Now when we applied a external force P on bell crank lever, so this bell crank lever moves inward directions and this block of shoes are attached to wheel or contacting with wheel. So when apply the force P, the brake will applied. Now the main points noted down in double block brake. This is the very important. First point, in single block brake, when it is applied to a rolling wheel, the load is thrown on the shaft bearing due to normal reaction. This produces bending on shaft. Please see in previous figure, in this figure. This is single block brake. Please see in a figure. This is the wheel and this is the rotation of wheel. When we applied on external load P, so normal reaction is in upward direction and load is applied on downward direction. So the bending effects acts on rotation of wheel in single block brake. In double block brake, we attached another shoe brake and levers. When we applied a downward force and here is upward force, so we can balance a bendings in wheel or shaft. Now here is mentioned is very clear. In single block brake, when it is applied to a rolling wheel and load is thrown on the shaft bearing due to normal reaction, this produces bending. Now in third point, this is very important. In order to prevent this by means bending, double block brake is applied for applications. Double block brake, to avoid the bending, double block brake is used. In double block brake, bending reduces or eliminations. The formula of bending torque here is TB. TB is Ft1 plus Ft2 into R. Please see in a figure Ft1 and Ft2. When wheel rotates clockwise direction, then this side of Ft is in upward direction Ft1 and this, and in this side ft2 applied downward direction, ft2, and this is the radius r, and this is the radius r. So tangential braking torque Tb is equal to ft1 into r plus ft2 into r. Both are plus because ft1 in upward direction and ft2 in downward direction, and both are making a same couple is in clockwise direction. ft1, ft2 both are makes clockwise couple. So tangential braking torque equal to ft1 into r plus ft2 into r, and r is common, so Tb is equal to ft1 plus ft2 into radius of wheel r. This is the formula of tangential braking torque in double block brake. Now today will ends. Thank you for watching my video.